Welcome to the Glassworking shop. Well, the assembly went really well, and the pull it's pretty good. I'm still not a perfect puller yet, but since I resized the pieces, it kind of doesn't matter. It's kind of like close enough is good enough. So here's what the pull looks like. It's got minimum distorted knuckles, where the glass kind of behaves funny anyway, and even if I did pull it down to a perfect size throughout, the ends would be funny and wouldn't be very useful anyway. So I ended up with approximately a little under 9 inches, like 8 7/8 inches of usable material. And considering saw kerf and all the other things that are going on, I basically cut them up into 6 pieces, 1.25 inches long. And here's a photograph showing how they fit together before resizing. So they're not quite close enough yet, and they're going to be doing a resizing operation next. I wanted to say a couple of things about the process, because it's, first of all, it's a very, very wasteful process. I mean, I haven't actually calculated it, but when it finally ends up being one of my sculptures, I'm lucky if I get, I don't know, 20% usable glass out of all the glass that I use. And I keep thinking about it and imagining, well, how can I make it more efficient? But there's always waste in glasswork. There's always knuckles, there's always ends, there's always cutoffs, there's always leftovers and shorts. And so, yeah, I'm going to continue to think about improving efficiency, but right now, you know, I'm not doing this to make money, and the cost of the material kind of doesn't matter. I just like making cool stuff. So, you know, I can tolerate the waste at the moment, but I hate waste, and so I'm going to continue working on trying to make it more efficient. The other problem that I'm facing is when I'm making prep, I'm trying to kind of like somewhere between compute and use intuition about how much prep do I need at stage 1 in order to make stage 2, and then stage 3, stage 4, stage 5, stage 6. And considering that a lot of this stuff has many, many steps, it's kind of hard to estimate, you know, what size I need to make at the beginning, how much I need to make at the beginning. And as I said in the previous 3 videos, I actually came pretty close in my estimate of putting together that last assembly. It almost hit the target perfectly, about a 2-inch on-side triangle, approximately 4 inches long, which was then pulled down into a nearly 9-inch long piece, 1.25 inches on a side. So I've got a couple of fairly large punty and moil assemblies that have been made ahead of time, and there's nothing exciting about them. They're boring as boring can be. So next thing I'm going to do, I'm going to resize my little cut pieces, my 1.4-inch cut pieces, going to resize them in the squeezer. And then, because I've been told by at least one experienced glassworker that minimizing the number of heat-cool cycles is good, that it's easy to overwork glass in a complex process like this. And when you overwork glass, it starts breaking down, chemically breaking down and outgassing and producing bubbles. And, you know, bubbles are not our friend in the marine world. So I'm going to be resizing and assembling while the pieces are still hot. This is a new technique that I've just kind of figured out recently, and it seems to work pretty well. I'm going to be using an assembly jig that I made a while ago as a Chipstack Assembly jig before I came up with the Chipstack Assembly Kiln Fixture thingy that doesn't have a cool name. And so I'm going to be using my older generation Chipstack Assembly fixture to hold these pieces together, and then stick them on the end of a big moil, squeeze them into their final form and pull them down to hopefully a precise target size. So, time to get going. I've got the assembly moil sitting there over the Bunsen on the NQALHA, and now I'm gonna actually, hard to remember all the steps in the sequence, but I need to reconfigure the squeezer for triangle squeezing because I had it configured for hexagon when I was doing the, so I had it configured for hexagon when I was making the moils, so I'm a little confused there for a moment, talking and working at the same time. So, same procedure as always. Preheat the tongs. Don't want to shock the pieces any more than I have to. And very carefully, kind of difficult to manipulate these little guys, and they're barely enough to hold on to. Take this glove off. So I'm just heating the end of the marine hot enough to stick, because I don't want to distort the pattern any more than I absolutely have to. Don't see any kiln dust, and so I don't have to worry about that. I'm going to preheat these little guys out in the far flame. They have been in the kiln for an hour or so, but still, gentle is good, especially after all the work that's gone into these. I certainly don't want them to crack or explode. They were properly annealed. They did go through a complete correct annealing cycle. And they're reasonably close to the target dimension. Trying to avoid overheating the corners, slowly letting the heat soak into the core. Trying to keep my little undersized punty stabilized. Glasswork is all a balance, and none of it is easy, I tell you. So, I'm going to just touch it into the squeezer here. Not very aggressively at all, mostly just to cool the surface. Every time I stick it into the squeezer, as soon as the glass hits the graphite, the surface freezes immediately, but it doesn't do anything to the core heat that I'm slowly building. And so by cooling the surface, I can build core heat without overheating the surface. So this one is very, very close to target dimension as pulled. My pulling is getting a lot better. I'm still not as good as the best I've seen, but I'm a whole lot better now than I was before. So, one more squeeze, this time with vigor. This time standing on the squeezer and looking at the little piece, and looks really, really nice. So there's one. Now, not really sure if I might just fast forward through the next 5, because kind of like once you've seen it once, you've seen them all. I do want to make just one more little comment about this work, especially when trying to improvise a narration. Really, really hard to avoid making mistakes when doing this. And especially when doing 2 things at one time. I've had problems in the past where I tried doing 2 things at one time and ended up dropping a piece of glass because I was thinking about something else. So, looks like no kiln dust. They were stacked on their end. Most of these pieces are almost good enough to use, and there's a chance that I could have used them just as they were, but I love precision. So slowly heating in the far flame. Of course, when I'm making these videos, I partly make the videos because I can show how my machines work. I also just like making videos, but there's always a question, how many times do I show the same thing? And one way of thinking about it is, well, if I was being economical, I would show every operation exactly once. And if somebody was interested in seeing an operation, well, you could go back 2 years and see the first time I did it. But then I look at some of the videos that I watch on YouTube, and there's a machinist I watch who must have indicated a part on a 4-jaw chuck 5,000 times. And yet he shows every detail of it, every video. It's like, okay, now I'm going to indicate this part in. Or like the guy repairing watches. Now I'm going to use the special cannon pinion removing tool to remove the cannon pinion every single time. So, maybe I should think of it in terms of, maybe this is the only video you're ever going to watch. Maybe I shouldn't assume that you've seen any of this before. Or who knows, maybe nobody watches the videos. I don't know, maybe it's all just robots. Okay, another very nice one. They are coming out really, really good. Rinse and repeat. Kind of hard to see in the kiln. It's kind of dark there, and I'm wearing dark glasses. And if I drop one of these little guys, I'm going to really be in trouble. That is very close to unrecoverable failure. So, stick it on. Slowly heating in the far flame. And then, of course, it's probably a good time to remind everybody that the NQALHA is still on duty, keeping that assembly moil that is going to be used in the next operation, keeping that guy hot and happy. Hard to believe it's been 7 years. 7 years just recently that I started glassworking. Of course, I've been spending a lot of time in the machine shop, and so I can't really say I've had a full 7 years of work. And of course also, I've seen very talented glassworkers making amazing stuff after 2 years, so, you know, I do my best. And when I can't develop the skill, I invent a machine. So this one is a little bit more, this one is one of the closer to the end pieces, and so it's a little bit more troublesome. But it appears to be shaping up really, really nicely. Another comment that I can make just about the physics of glass, that even if I was an exceptionally proficient puller, the glass itself distorts when pulling a triangle. And there's that little guy, really, really nice. The glass itself distorts when pulling a triangular shape, or actually any shape that isn't round. And so the points tend to get exaggerated and the faces tend to develop a bit of a concave shape. And so even if I had the amazing skill, they might still require resizing. Okay. When I'm resizing a piece that has a big end and a little end, I like to have the little end on the puntee and the big end toward the bottom. Makes it easier to compress the big end when it's facing downward. Just a geometric thing. I'm not sure exactly why, but actually I am sure exactly why. It's easier to get the big end hot, because if I put the big end on the puntee, then I'd always be losing stability as I was heating it. So yeah, why did I say I didn't know the answer? I know the answer. Big end on the bottom, little end on the top. So Now, I know this has nothing to do with glasswork, but I like to talk when I'm working, and hopefully maybe somebody who's watching might even find my babbling to be somewhat entertaining. I've been watching videos that are recommended by the YouTube recommendation robot. And sometimes it sends me some really strange stuff. I mean, I don't watch pop culture at all. I watch people making things. People making things, teachers teaching things, but always try to learn something every time I go to YouTube. And lately, the robot's been feeding me hoof trimming. And I never even knew that this was a thing. That dairy cows require maintenance. And that there's a special rig that these guys tow behind their truck and take it to the farm, and it's got hydraulics and straps, and it lifts the cow up and prepares the foot so that the hoof trimmer can trim it. You know, you learn something every day. Never knew that was even a thing. So, the squeezer is amazingly effective at resizing these pieces. This guy started out standing on the squeezer for the final squeeze. This guy started out, this was one of the ends near the knuckle, and it started out pretty big on the big end, and now it's just about perfect. And of course, the term perfect is rather difficult for a machinist to apply to glasswork, because in the machine shop I deal with thousandths. In the glassworking shop, I have to adopt a little bit looser definition of perfection. So, here comes another one. So I haven't quite learned enough to go out to a farm and trim a hoof, but I think I can speak a little bit of the lingo. I can talk about, oh yeah, that cow looks like it's got a white line defect that allowed bacteria to get in and cause a sole separation and a sole ulcer. So I need to remove all of the dead hoof material, all of the overlying hoof material, and apply a salicylic acid wrap, and also apply a rubber block to the other hoof, the other claw of the hoof, so that that keeps the weight off of the injured one. My wife says, "Why are you watching that stupid stuff?" Oh, I don't know. But the truly amazing part of the University of YouTube, when I'm not watching stupid stuff, I can watch machinists with 40 years of experience. And since I'm already an experienced machinist, I kind of don't need the basics, but sometimes see somebody who knows a trick, a procedure, a different way of looking at things, and it's really valuable. They have lectures. Serious lectures by Nobel-winning physicists. I love the University of YouTube. And of course, there's just way too much stupid people doing stupid stuff to try to be famous. And I don't know, you know, if that's what floats your boat, go for it, but Me, I want to watch experts. And speaking of experts, for anybody who wants to see the best glassworking videos out there, I strongly recommend Revere Glass. They are exceptionally good videos. That's what got me started in glasswork, is watching Revere videos. Torch Talk is another great one. And if you're interested in furnace work and soft glass, Corning Museum. Absolutely amazing. World-class experts showing their work. And to me, this is the true promise. Back when, I've been around computers for a long time. I started in the 70s with mainframes and punch cards, when we were all fantasizing about a time when all of human knowledge is instantly available to everyone. And yeah, if you choose correctly, you can not quite have all of human knowledge, but there's a tremendous lot of stuff out there. And of course, some of it is just stupid. Some of it is just arguing with trolls. And in many cases, politically motivated trolls. Okay, last one. Careful as it goes. I need to turn this one around. That's one of the things about glasswork, one of the many things about glasswork that makes it so challenging. You can't touch the piece you're working on. And that will be number 6. One nice thing about working in the hot shop on a cold day, it's a lot more pleasant. We've got a historic storm starting to hit Northern California, and hopefully the power won't go out while I'm working. That would kind of suck. I do have a backup generator, but even with a backup generator, it takes a while to start it up, and glass doesn't like getting cold. So this one is also a little bigger on the bottom. Big end down, preferentially heating the big end and the bottom, using a little bit of gravity to try to get it to elongate a tiny bit. And then gentle first squeeze, barely just touch it. The most perfect way to elongate glass is to use gravity if you can do it. That's the most geometrically and physically correct way to do it. The squeezer is really great for refining and perfecting a shape, but if you think about geometrically what's going on, it's not really the geometry of the tool is not really making a piece smaller, because glass is incompressible, and squeezing from the side really doesn't make the piece smaller. And if it does it in a very distorted way, kind of pooping out the end in a way you don't want. So if you're trying to use the squeezer to elongate a piece, it's necessary to use a combination of squeezing and gravity. So, this one looks like it's coming along very nicely. Gonna stand on the squeezer for the final squeeze. And into the kiln it goes. So I now have all 6